Hours spent on cellular device per day versus average GPA of a 10th grader. Is there an association between how long a 10th grader spends on their phone per day and their average GPA? Here are the two dot plots of my data, the top one of cellular device hours and the bottom one of GPA of 10th graders. As you see, the majority of the data is around the 4, 5, and 6 hour mark, but we have a couple outliers near the 12.5 and 13 hour mark. And then the average GPA of 10th graders is pretty evenly spread around here, with a couple lower ones at 2.4 and 2.5. Here is the linear regression plot of hours on cellular device per day and average GPA of 10th graders. As shown by this line right here, the R is equal to negative 0.17, which means it's a weak correlation, but there is still a correlation to be found. As you can see, the dots are not very tightly packed together, but there is enough data to show an LSRL. Here's my linear regression residual plot. Notice the dots everywhere scattered around the graph rather than a pattern. This indicates that there's a linear pattern. And then if you look at the shape of the dots, there's no sideways Christmas tree. This is essential to the plan phase of the t-test and t-interval because it shows that there are not equal standard deviations. Here is the state, plan, do, and conclude for my linear regression t-test. For the state phase, I have my null hypothesis as the true slope is equal to 0. For my alternate hypothesis, I have it set as the true slope is less than or equal to 0. For my parameter, I have it as the true slope for the LSRL of the hours spent on phone versus average GPA of a 10th grader. My statistic is 0.0405. And my significance level has been set at 0.1. For the plan phase, the name of the procedure is linear regression t-test. For the linear checkpoint, yes, it is linear because my graph shows a straight linear line versus a curved nonlinear line. For the independence checkpoint, yes, it is independent because one student's choice doesn't affect the next student's decision. For the normal checkpoint, the dot plot of the residuals shows no pattern, therefore it's normal. For the equal standard deviations checkpoint, the residual plot does not show a sideways Christmas tree shape, therefore there is no equal standard deviations and we are good to go forward. For the random checkpoint, no, this is not a randomly picked observation. Normally this would warrant stopping, but for sake of trying to make a generalization, I will proceed with caution. For the do phase, all my work was done on the calculator, and it resulted me with a p-value of 0.098 and 52 degrees of freedom. For my conclusion, I said, because 0.098 is less than 0.1, I have convincing evidence to reject the null hypothesis and accept the null hypothesis. Therefore, we can say that we have evidence to show that there is a negative correlation between hours spent on a cellular device per day and the average GPA of a 10th grader. For my state, plan, do, and conclude for my t-interval, my state and plan phases are the exact same, with null hypothesis not changing. However, there is a difference in the do phase. This time, instead of showing a p-value, we show an interval, and my interval ranges from negative 0.0808 to negative 0.00029, with the same 52 degrees of freedom. For my conclusion, we are 80% confident that the interval from 0.0808 to 0.0029 captures the true slope of the population LSRL. Because both values are negative in my interval, we are 80% confident that there is a negative correlation between the hours spent on a cellular device per day and average GPA for 10th graders. One lurking variable that exists in my project is study habits of a child. If a child still manages to study 4 hours but get a bad GPA, one worse than a person who doesn't study but gets a good GPA, that influences the results of the project because it makes it look as though the child spent too much on their phone, but in reality they are not a great test taker. For my project overall conclusion, I write, after performing a regression t-interval and a regression t-test, some interesting results arose. For the regression t-test, I set it at a zero point 0.1 significance level. The results I obtained from putting all my values into the calculator gave a p-value of 0.098. Because 0.098 is less than 0.1, we have convincing evidence to reject the null hypothesis and support the alternative hypothesis. In the context of my study, the null hypothesis was that there is no correlation between hours spent on cellular devices per day and GPA of 10th graders. And the alternative was that there is a negative correlation between hours spent per day on a cellular device and GPA of 10th graders. Therefore, because there is evidence to support the alternative hypothesis, we can say that hours spent on a cellular device can affect the GPA of a 10th grader. For the regression t-interval, since the interval ranged from two negative values at an 80% confidence level, we have evidence to say that there is a negative correlation between hours spent on a cellular device per day and the average GPA of a 10th grader. Generalizations. Due to the results of my linear regression t-test, we have the proper evidence to say that there is a negative correlation between the number of hours spent on a cellular device and the 10th grader's average GPA, and that reducing hours on the device can lead to a higher GPA. In terms of the interval, because both values are negative, it also shows that there is a negative correlation between number of hours spent on a cellular device and a 10th grader's average GPA. Overall, the evidence I have is in favor of the reduction of screen time to increase GPA. But because this was an observation rather than an experiment should be carried out to verify the validity of these results. So, why? So why does this matter? Well, the topic of my research matters for a number of reasons. One of the bigger reasons my question matters is because if the results are true as that show, I could find a way for 10th graders everywhere to increase their overall GPA, which would let them enter colleges they might not have previously been able to get into. Also, with better grades, the child could better impress their parents, which could lead to a healthier and happier at-home relationship. With the child's better relationship with their family, they could have a better outlook in life. Project improvements? Yes, there are a few possible improvements that could be made to the study that would much better increase the results of the study. One of them would be way in which it is carried out. Currently, the study is an observational study, which means that all the data was obtained by method of observation. If data was gathered randomly assigning people to groups, as stated, I would go about the experiment by first a lot of bias would be reduced. As stated, I would go about the experiment by first taking everyone's name and assigning it to a number. I could create 5 groups, each with different amounts of screen time spent. I would then use a number generator to pick random numbers and assign them to a group until it is full and then move to the next group, while ignoring repeats and numbers above the highest number in my set. With the combination of random assignment and having set hours in each group, I would be able to see the ability of student limited to amounts of screen time so that they could not say they do less than they actually do. Thank you. Coach J, you better give me an A.